Hi, everyone. We are here at the MVP Summit in Microsoft Redmond. And hi, Håkan.
Hi, Jonah. How are you?
I'm doing great, having a great time at the Global MVP Summit where I get to meet all the awesome MVP friends from across the globe and really feel that community spirit and learning as well. So it's awesome to be here. And we also have an opportunity to be at the Microsoft studios here in Redmond where we are recording and sharing a good learning content
Mhm.
and presentation. Tell us about it, Håkan.
Yeah, actually, we can't say so much about the actual content of this week here, but we're very grateful that we can be here at the Microsoft DevRel Studios and do a recording. And I also think it's really nice here to do recording in person because even though we've done recordings for a number of years here, they have mostly been virtual, but it's a different thing here and more fun here to do it in person.
Yes, exactly. And we are the leaders of Azure User Group Sweden. So I traveled all the way from Sweden and Håkan from Norway to be here at the campus. But it's good to share more about what we're gonna share. So today we will be sharing about building applications using Azure AI and MCP servers. So we probably need to share our screen on this one. Great. So today, Håkan and I will be sharing about building apps using Azure AI services and MCP servers. But before we do that, let me introduce ourselves. First, I'm Jonah Andersson. I am Microsoft MVP for Azure. I'm from Sweden and I work for myself, for my own company, Jonah Andersson, the Tech. I am someone who likes to inspire others about what I do, and that includes community, Azure, and my focus is .NET development, DevSecOps, Azure. I'm the author of Learning Microsoft Azure, Cloud Computing and Development Fundamentals at O'Reilly. And I'm currently writing the second edition of it, which has a focus on AI native. Aside from that, I am a community leader of Azure User Group Sweden that I host with Håkan. MCT community lead. I podcast on my spare time along with another developer called Extend Women in Tech Podcast. And I am also a dog mom to a cute Labradoodle, Lawrence, that you see in the photo, smiling back at you on this presentation. So that's a bit about me, and I'll let Håkan present himself to learn more.
Yeah, so my name is Håkan Silfvernagel. I've traveled here from Oslo, Norway. I have more than 25 years experience here in the business as a developer, an architect, team lead, a tech lead, many different hats. So I started that as an Azure developer, but I've been focused on artificial intelligence since 2016. And I believe that it's important here to keep updated. So my motto is to be a continuous learner. So I have taken more than 40 certifications on cloud, data, AI, on the major cloud platforms like Azure, AWS, and Google Cloud Platform. I work as a senior AI architect at Soprasteria, and I'm also involved in the community. So as Jonah mentioned, I'm the co-organizer of Azure User Group Sweden, but I'm also the organizer of Norwegian.net User Group and the organizer of Oslo AI. I'm a Microsoft AI MVP and also a Microsoft Certified Trainer Community Lead.
Awesome. It's like the powers combined. Powers combined. We're both MCTs, we're both community leaders, we're both MVPs, and imagine us creating, recording this video and sharing content about Azure AI and MCP, which is like power combined because Håkan is an AI MVP and I'm Azure. So we're combining our field of focus and skills in terms of .NET development and more. So I want to start, Håkan. This is going to be like a presentation, a bit of discussion with you as well. But we don't have much time, but we have a lot to present. So what we will do is we will be sharing the basics of what MCP server is, It's very trending right now, but you need to understand what MCP is before you can get started developing with it with AI or Azure services. So I will be going through the concept and a bit of discussion with Håkan through the presentation, and then we will be Håkan and I will be presenting to you how we would how would you would literally build the application with this services. So I want to start and kick off by asking Håkan a question. So there will be like a discussion, and even you that's watching us, like to reflect. As developers or someone learning AI, what is your greatest challenge when you're working or coding with it? And instead of me answering it, I will ask my colleague and co-leader Håkan what he thinks about it.
Yeah. As I think one challenge here is to know where to start actually, because there are so many different options for us. We can either choose like a low code solution using Copilot, or we could use more pro code using Azure Foundry, using Azure AI Search, or we could do something in between, because it's also possible to develop an agent in Copilot Studio, and then you have a backend that connects to Azure AI Foundry and Azure AI Search. So the topic for today here is about agents and about MCP servers. So we hope that after this session, you will have a good understanding here of what is an MCP server, and hopefully you will also see that it's not so complicated to set an MCP server up. And you will also see how can I create an agent, and how can I create a client that can help this agent consume these services.
Yes, that's exciting. Thank you, Håkan, for that. So I want to share also that I did attend the Microsoft Ignite, and I'm also involved with different like interactions with developers as I speak at conferences and meetup, and also learning myself as a developer in building agents. And one of the challenges, probably you all can also have noticed this, and can relate to this list, is some of the challenges is that questions that most developers ask is that, where do I start building an agent? And then another question that many developers have challenges is asking the question, how can I make agents work together? And how do I know what my agent is actually doing behind the scenes with my applications? And another way is like how to deploy and manage these agents, and where do I have a good user interface to handle or to make management on this agent. So those are like the common challenges that most developers has. But if you're someone that's new in AI agents, so maybe Håkan can share what are AA agents in this perspective.
Yeah, so the basic here of using an AI agent is that the AI agent's using a language model, or we call it an LLM. So the LLM is able to understand our question, and it's also able to go into specific data and retrieve the kind of data that we're asking for, and then give it back to us in a natural language here. So we can also have a workflow with agents. So that means that you set up that the agent first should do one task, and after that it will take that result and go to do the second task. And then finally it will sort of compile a report or compile an answer and hand it back to us, the users. And the nice thing here with the MCP services, that gives us like a standardized method or methodology here for creating this, which makes it much more easy both for us to write the MCP server, but also for someone else to consume these tools that the MCP server allows.
That's great, and it's a very good basic to really understand how AI agents work before we get started. So this is one good example that we have, Håkan, and probably you are also familiar with this very well since you work with this day to day. So this is an illustration or diagram that is reference from Microsoft Learn documentation. So probably Håkan has a better take on how this works, since you're an AI MVP. So I'll let you do that.
Yeah, so in this picture, we try to illustrate here that you have an agent, and the agent uses a generative AI model, and it also uses instructions or prompts. So these instructions or prompt will tell the agent that maybe you are an expert in order handling, and you know everything about when orders are executed and what the storage looks like, and so on. And then we have tools. So the tools is actually functions that this agent can use. It can be a function to do a web search. It can be a function to go into your order system, to go into your finance system, or whatever you have. And these tool calls, they can be used either to retrieve information or to perform an action, or you can also save things from a previous session. So that is called memory, so that we're not memoryless. So the input here is either a user message, it could be another agent that is communicated with another agent, or it can be a system event that triggers some sort of action here. And as an output, we get an agent message, or we get this tool result, which is basically the result from this tool that we've executed.
Yes, and I would like to add a bit about tools because I've been experimenting or learning a lot about the new Azure Functions MCP tool trigger, which is, I think, currently, as of date of this recording, is on preview. So it's a very good tool, especially if you're working with AI agents along with .NET, and at the same time you want to use MCP servers and Azure Functions for that. So how does this is how an example of how agent AI agents flow looks like. So as Håkan actually described it already, like how the process looks like. So we have kind of like a role of a user, then you have the agents, and then the language model, LLM, as well as the tools or the MCP that are involved in the entire flow process on how it works. So here you have a user message in which initializes the instruction for the prompt. And within it, you do see both actually two loops. So if you see the yellow one here, there's like the agentic loop, which is an iterative task that until the task is completed. And in that agentic loop, there's a request. Or within that, the user can send a request, a prompt, and a context. And then the agent can decide for the next action, just like how it is. And then if a tool or an MCP call is required or integrated into it, it will also do the same process within that. So there's an agent and LLM involved in and tools as well. And then the final results will be sent back to the user, just like when you're programming APIs, you kind of like try to get the results of the data that you're retrieving from the database or retrieving from another API. Actually the same way. If you're pretty new to this, it's actually the same way, except that you are like integrating language models and AI within it with a bit of better process in between. Do you have anything to add in this illustration, Håkan, that I probably missed?
No, I think it's that's a good illustration here.
Yes, that's great. So there are different ways to build AI agents for us. So probably some of you or a few of you have tried it, and maybe some of you who are pretty new to this have not tried it. So we have the Foundry agents. We have Copilot Studio if you prefer low-code development for building and deploying agents. We also have the Microsoft Agent Frameworks, which is very ideal for .NET developers or Python developers because it supports two languages right now, and it's very good, like SDK you can call it, or kit for developers to build something with AI or AI agents that can be integrated with Microsoft Foundry and the language models available there, as well as Agent Builder. There's Autogen, the Microsoft 365 Agent SDK that allows those like developers that prefer to use this as their way to build agents. Have you used any of this, Håkan?
Yeah, so I've used the Foundry Agent Service and Copilot Studios, also the Agent Builder, Microsoft 365 Agents SDK, the autogen. Yeah, so I've
Wow, you
basically
bet.
used many of them.
You
But
bet. Oh,
yeah.
yes. Great. Awesome. You're awesome. Go ahead.
Mm. And one thing I was noticing here is that in the past we also had a framework called semantic kernel, but now semantic kernel and autogen has sort of been combined into this Microsoft agent framework. So going forward, that's sort of the framework that people should be using.
Yes, I highly recommend the agent framework
Mm.
actually for the developers. So probably you know the answer of this, Håkan, but those that are new, like developers, are still in the early phase of this. We question ourselves because I myself also is in the learning phase. All of us are learning and building things with the new technologies, and it's rapid, it's going fast, and we're trying to go with the flow of the phase, but it's not easy. But you need to know why AI agents matters to us developers that are building with it. And these are the list of four things that are relevant, at least based on my research, that automating AI agents are good for developers because it help us automate some repetitive tasks that would consume a lot of time and resources instead of us focusing on the logic and problem that we want to solve. It is very good in developer productivity, such as like real-time coding suggestions or helping with testing, helping with PR. We know that Copilot, GitHub Copilot can help us that already as we develop locally or even in our like source control. It can help improve our code quality if there's a team of developers that have missed a few things by normal hands-on. So it's a good code buddy or co-pair programmer. It does help with the detection of like a few things that was missed, best practices, refactoring, and going back to the best practices by using, like for example, one of the MCPs that are known at the Microsoft stack today is the Learn MCP server. By using that MCP server within the VS Code, you are able to connect, query Copilot if you're following the best practices or there are things that needs to be improved in your source code to improve the application's quality. And of course, it's an intelligent assistance for everything that you need to do. But anything else you want to add in this, Okan? Why is it I said that I probably missed?
I think it's
Mm.
important here to realize that we are in a very important change here. So people will clearly talk about the time before we had AI agents, and that could help us with coding, and after. So this is a very relevant topic here for anyone who wants to go into development, and actually for most other people too.
Yeah, exactly. So, and we want to build, as we are MVPs, right? We are experts in what we do, and we are the front people or frontliner, forefront of like sharing this to the community. And I think it's very important to not hop into, I mean, in my perspective and speaking from the heart, to not only hop into the advanced level, but also being able to really understand the fundamentals and not just let do right away do prompt into engineering, which is very common today, or vibe coding without truly understanding why it does what it does. So that really makes a difference. So when do we need to use AI agents? So customer support is very common. Like if you have a need for multi AI agents, debugging, code generation, and most importantly, like if you need like customers some kind of assistance, which is widely used by many organizations today or even businesses where they use AI as their customer service assistant. Like I myself have to interact with a chatbot from time to time if I need customer service help with my airlines, my travel, or my billing. But of course, sometimes AI cannot do everything, and we need to have human in the loop. And that's when being able to build AI agents in a workflow is very relevant because that allows us to build applications that put human us in the loop to take over if it is necessary. And then education and tutoring is also very good when to use AI agents, and anything that is uh, time consuming that we can automate, it's a good use case for using AI agents. And when not to use it, Håkan?
Yeah, so I think we need to understand here that when we're using AI, we're using something called like a stochastic model, which basically means that it's statistics that will give us the answer. And as we know from statistics isn't always right. So we have to take into account that when we're using AI and AI agent, we will not be 100% right all the time, and we will not get the same answer back either here. So so as Jonah mentioned here on this slide here, that if we have a task that is highly structured, then we can instead use a rule-based approach instead of using the AI approach.
Yes.
And in addition to that, we can also think that maybe sometimes AI may not be the right tool to use. Sometimes maybe you can use automation, you can write a Power Automate flow, or something in this matter. So AI is not good for everything.
Yeah. Okay. Yes, exactly. And it depends on the use case. So when to consider like workflow, because I know that you can use and you can build something with one AI agent. That's just one, but you can also consider having a workflow with AI agents. That's why there's like agent to agent and agent to multi agents talking to each other. But you consider it like, for example, if you have a sequence of operations that needs to be predefined. And then if you have like long running processes that needs to run multiple, and there are different AI agents involved, like for example, in a typical store, like think of it like you would need probably an agent that will handle the customer service. You might need an agent that will handle the billing management, and probably an AI agent that will help the order management and delivery. So it depends on the use case, but sometimes there's this flow, and maybe you need human interaction involved and integrated with that as well. And then if you need to have this like model based decision making and concurrent execution when it comes to that. So so these things that we have like AI agents, they're pretty new. We are still getting started, but we have these questions. I mean, especially those that are new. Probably you and I, Håkan, I kind of like a pretty good basic understanding about what we're talking about, and we're in the experimentation phase and learning from it. But imagine those that are like new in the technology and just getting started. We do have this question: how can we get started with this? What is it, and why do we need to learn how to build with this AI agents as well as MCP? And one of the things that I highly recommend, if you're working with Microsoft technologies when it comes to building AI agents, I would highly recommend you, if you don't know how to start, is the Microsoft Cloud Adoption Framework for AI agents, or we call it CAF AI Agents Adoption Workflow. And in this workflow, as you can see here, there's like a few phases: 1, 2, 3, and 4. So the first phase is going to be like you need to plan. Of course, you need to have a business plan, technology plan, and your organization needs to have a good readiness and preparation for that. And of course, data, because data is being used by AI or language model to learn. So you really need to plan all those things, and also plan what kind of agents you're going to need. And of course, the number 2, once you have that, you need to think about governance and how you can secure your agents, such as responsible AI. And responsible AI actually depends also on where you are, because I know, Håkan, in Europe we have the European AI Act also happening. Governance and security. And then once you have that, then you're ready to prepare and build the agents and then manage it. And that's when you can use the tools that we list out, like the Microsoft agent framework for .NET and other tools as well. That's the part. And it's very ironic because we both are in the software development, Håkan, and usually we start by planning and then build it. But when it comes to building with AI agents, we really need to think about the responsible AI part, the governance, because usually in the application it goes at the end after you're in the management phase and operation phase. But that's a very good flow. So tell me, Håkan, this is my quote. I mean, I made my quote about trustworthy AI, and let me just share briefly why I think building trustworthy AI matters. It's because, like, with the tools that we are building right now, everything is evolving and it's getting fast. But I do believe that we need to question ourselves: Are we ready? And if we're not, then we need to prepare for that. Can we trust the AI that we are integrating into our systems today? Like, do you just pull whatever is trending right now? I recommend that don't do that. Read or watch carefully what you are integrating your systems with the AI. And if possible, build it from scratch. If you have the skills and competence and opportunity to learn by building, and make sure that if you're a developer, you're building quality AI powered applications and not just deliver quick and fast, just like the technology. So that's my, like, kind of like a quote. But probably you, Håkan, has something to say about trustworthy AI, since you work with this at your
Mm.
work.
Yeah, so usually in the project you will have like a checklist of
Mm.
things that you need to take into account, and that goes all the way from data. Who has access to data? Is there an API, personable identifiable information in the data? How was it trained? Is there a bias in the models, and so on? Just to make sure that we are doing this in a sort of responsible fashion.
Yeah, very, very relevant. And when it comes to responsible, there's actually 5 dimensions of AI trustworthiness. And you might be asking, Jonah, Håkan, I thought we're talking about building applications or AI agents in Azure and MCP. Yes, we are. We're gonna be, and we prepared a good demo for you guys. But we want to share also the very important aspects when it comes to building, things to think about to prepare. And these are like, we want to share the 5 dimensions of trustworthiness as an overview. It's actually very detailed later that you can check on Microsoft Learn. But when it comes to building responsible AI, you need to think about and test how trustworthy the AI tools that you're integrating or you're building with. And these are like the characters that you need to look into an AI. Can this AI be trusted? Just like how you trust your friend to talk to. So when you chat with ChatGPT or an AI app, you're telling something or asking questions that might be private or sensitive to you. And as a person, human to human, you want to make sure that that person you talk to is someone you can trust with. And same goes with our relationship with AI. We need to trust it. So the common characters is like transparency. Is AI transparent? The company that's building AI, are they transparent about what the AI does? Accountability. Is the tool accountable? Is it secure? Is it reliable? Is it fair to everybody, like inclusion and everybody that are the data that are being used for that? So always evaluate AI systems in these dimensions. And if you see a risk, a weakness, that is something to be careful and to watch out for. Håkan, any input in this?
No, yes, as Jonah mentioned, this is
Mm.
really an important subject here, an important topic.
Yeah.
So it's important there not to use technology just to use a new technology, but to use it in a responsible way.
Yeah, exactly. And very relevant. And I believe I want to discuss a bit about like Microsoft Foundry Agent Service, which used to be like Azure AI Foundry. So just want to highlight that some of the characters or AI trustworthiness as actually built within the Foundry Agent Service as well, where you have the number 6 there, the trust and other tools for its flow. And just an overview, this when you're building with AI, there are like, of course, lots of tools for it. But you can, as a developer, you can build with Microsoft Agent Framework, which is very good, supports .NET and Python, and then also the Foundry Agent Service. Håkan and I will not be like digging into that in details, but it's worth knowing that it exists if you want to build declarative agents, hosted agents, or workflows for multi steps integration with these agents available. So I'll let Håkan like share a bit about what MCP is.
Yeah, so as we mentioned here at the
Mm.
start of our presentation, we would like to have like a common way or a standardized way for the agents to be able to communicate with an MCP server, and also to be able to find out what kind of tools does this MCP server provide. So that's why we have this model context protocol. And as an illustration, you can see a similarity between the MCP server and other standardized protocol, like for example the USB-C, that has standardized ways that we can connect devices here to our PC, for example.
Yeah, exactly. And you can think of MCP servers as MCP, actually. It's a server, the server and the client. The MCP is a protocol that actually removes the limitation of AI that it used to have. Like now with MCP, AI can learn from real world data instead of just like dummy or test data. And it help us build applications in a more like effective and more context aware way as well. This one I think we can skip, but I can tell this was actually an example I have. What is MCP? So MCP is an open standard protocol, meaning it is not like tied into one specific platform like Microsoft. It's open source or open standard. It was built by Anthropic in 2024, so where it's actually spreading its popularity very fast, and it helps discover and call external tool, just like what Håkan also described, that it's like the USB, external USB that you plugged in into your AI application, and you get to learn about that application instead of coding it from scratch or integrating it by scratch programmatically or by code. So what it does is, as the illustration, you have the tools, the resources, the prompts, and the transport. And when it comes to the tools, you can think of it like Azure functions that can call or read a database. And then the sources can be the data or files that it can read. And then the prompts, and then the transport can be like your ID, like VS Code locally. Or if you're using Azure functions, you can access it using HTTP or SSE. And just briefly, because I think probably we're running out of time and we need to do some demo, we do have different ways. So just an overview of the MCP communication. So you do have like an MCP host, which is considered the AI application. And in that host, you have your MCP client, and each client can have a one-to-one connection with an MCP server. And an MCP server can be a file system, a database, or an API, or a custom MCP that can be called as well. So this is like how the big picture looks like. This is from MCP.io. It's like the official documentation of the MCP. So the host can be your Claude, IDE such as VS Code and tools. And then you do using the MCP protocol or protocol itself, you have your servers that can talk to a local data source from different resources, or it can be talking to a remote service or a remote data calls or web APIs. And we have a few concepts that we need to learn because it's very important before we dig into the demo. But why MCP matters for agentic AI development? And this is when we do the red and the green. Like before MCP, the integration between systems or APIs has been like complicated, like with AI. Like for example, you need custom code for every language model or a combination of tools. But today with MCP, you can have one protocol the MCP, that works properly or well with different tools such as Claude, the GPT, Gemini, and then all these other tools as well, such as like the model updates that can break integrations before MCP, but now you are able to swap between different language models without rewriting your tools. So these are the list of things without me kind of like explaining it, but these are the good stuff why we need to consider MCP as well as our alternative. And here is like a big illustration. I hope that you can see the entire screen, but you do have AI client talks to an MCP server through the MCP or the protocol. And then it can also have a communication to Azure, such as like Azure Functions, Cosmos DB, and Azure Services and AI search within it. So you do see that the protocol being used is the MCP JSON RPC 2.0, and this is an example of the flow. And if you're someone that's like getting started with MCP, and you might wonder what's the difference between MCP and doing REST API. Actually, I think the Håkan, they're not exactly the same, right? I mean, they are like completely different like technologies or way of communication, but MCP makes it easier if you're building with language models or AI. So, but here's like the side by side table where if you take a look at the discovery part of the REST API here, so it is usually manual and documented through like Open API. But if you are using MCP, it's more self-describing. And both REST API and MCP are model agnostic, of course. But when it comes to stateful sessions, REST API doesn't actually do that, but the MCP does. And then the authentication actually varies on the REST API when you're integrating it with your applications. But with MCP, it's built in because the authentication actually happens, I believe, in the server, like where that tool is from. Like let's just say Azure MCP server. So you are authenticated in your CLI or your IDE as you're logged into Azure. I want to use Azure MCP server in my IDE, then automatically you're authenticated and you don't need to code it. And then Azure hosting and complexity is a bit like low medium as well. So now it's time for demo.
Okay, so now we're back here, and as
Yes.
Jonah said, we're gonna have a look here at a lab. But before we dive into the code, let me switch over here to my browser. So the lab that we're gonna show here is part of a learning path on Microsoft Learn, which is called Integrate MCP Tools with Azure AI Agents. And we will leave a reference to this in the description so you can watch it yourself. And more specifically, it's a lab that is part of this learning path, which is called Develop an AI Agent with the Model Context Protocol MCP tools. So let me switch over here to Visual Studio Code. So what we're going to do here now is first we're going to show how can we use an already established MCP server, the Microsoft Learn MCP server, and how can we create an agent. And then we want to ask a question. We would like to have some configuration here for setting up a server, for example. Then we can ask the MCP server that. And then when we have explored how that function, we're going to write actually our own MCP server. So we're going to have a look that it's actually not that complicated to get an MCP server up and running. And then after that, we will create a client that will use this MCP server, and that we will be able to ask some questions here. But I think it's the easiest way here is for me to actually just start my agent here. So what is happening here when it starts, and we can also say that the examples that we have here is done in Python, but you will also be able to do this also in .NET. So basically what we have done here is we have created our agent. If I scroll this thing up, and then we ask a question. We ask it how we want to have the Azure CLI commands to create an Azure container app with a managed identity. And then we get here the commands back. So it communicates with the Microsoft LAN MCP server. And then here we can see that it's AZ container app create. And then we have, we can fill in our own resource group, the app name, the environment ID, and so on. And if we want to have a user assigned managed identity, we get the same kind of commands here that we then can use in order to create our container app with an Azure with a user assigned identity. And in addition here at the end, we also get references so that we can go back and check, does this actually make sense? Or maybe I have some questions that was not answered, or I need some more details here. Then I can go back and check that in the references. So if we switch over here to the code, then we can see here that the first thing that we need to do before we start anything of this is that we need to deploy an LLM LLM model in AI Foundry. So in Visual Studio Code, we can see here we have an extension here so that we can have a look into our AI Foundry. And if we look at this extension here, then we can see that we have a model. So in this example, we're going to use this model, the GTP 4.1 model. And if we want to use this in an application, what we can do then is we can right click here, and then we can copy the product endpoint and the product API key, for example, here. And then we will put this into an environmental file that we have in our solution. So I'm not going to show you how that is done, but you will be able to see that in our code that we will also be sharing here on GitHub. But basically, we first read the environment variables from the env file. So then we can see what is the project endpoint, which is the Foundry project, and what is the model deployment name. So in this case, it's the GTP 4.1 model. So when we have the project endpoint and the model deployment, then we can create here a client. So then we're using the product endpoint, the credentials, and we get an OpenAI client. Then the next thing is, since we're going to use MCP, we need to be able to initialize this agent with an MCP tool. So we create an instance here of the MCP tool. We have a server label, and here we have the server URL. So the server URL points us to an already established MCP server. So this can be any type of MCP server, but for this demo here today, we're using the Microsoft LAN MCP server. Then when we have that, so now we have the MCP tool, and then we can create an agent using this MCP tool. So we create an agent using project client agents create, and then we give our agent a name and also a definition. So here we're using the model deployment, the Foundry model, and also we're using giving it a prompt instruction here. So we're saying to the agent that you are a helpful agent that can use MCP tools to assist users. Use the available MCP tools to answer questions and perform tasks. And then we also need to have this MCP tool that we just created. We put that into an array. So that also means that you can have many different tools. So in another example, we will have 2 tools, for example. But in this example, we're using 1 tool, the MCP tools. And then we print out on the console that we have created our agent and some information about our agent. And then we start like a loop here, a conversation thread. So, and we also give a conversation ID for our conversation thread. And then we start an initial response here. So we say, give me the Azure CLI commands to create an Azure container app with a managed identity. So the idea here is that then our agent will send this input over to the MCP server, and then the MCP server, using one of the tools, it will be able to retrieve this Azure CLI commands and give it back to us. Then we create here an input list so that we can process the inputs that we get. And then after that, we create here an we send this approval here so that we can get the response back from our MCP server. So we can see here that it wasn't so much code here in order for us to create an agent that can consume an MCP server. And what is important here is that we have never defined that we want to specifically specify that we want to have these Azure CLI commands for an Azure container. We didn't need to write any code in order for us to do that. And this is the strength here of using agents and using the MCP server. So we sort of we put that responsibility over to the MCP server and on the tools. So basically, for us as developers, the only thing that we need to know is how can we retrieve the tools from the MCP server, and maybe there are some arguments that we need to communicate with this tool. So now when we have done this thing here, we can go over here to the next example here. Unless Jonah, do you have any further comments here about the agent that communicated here with the MCP Microsoft Learn MCP server?
Yes, no questions. Very interesting, because I'm more into the .NET examples or like side, but I know that you can also do this using the Microsoft Agent Framework as well. But one thing I want to add is that you're, as you also Håkan said, you're not limited to just using one agent. In the example of Håkan, he used the Learn MCP server, but you can also have multiple agents working together in your own applications, such as like if you want to integrate GitHub, for example, or Playwright for testing, you can do that. Or you can also build your own to customize it and maybe later on introduce it into some kind of workflow. But other than that, do you have any based on your example here, Håkan, and learnings from this demo, anything that you want to share to the audience in terms of getting started, challenges, and things to think about in preparing the environment, for example, and all this stuff? Like, because I know when you are developing, I mean, if you're a back-end developer, you can just like run the code, press F5, then it works. But when you're developing with AI, you need to think that, hey, you have an MCP server that needs to run first so the client can talk to it. So I know I kind of like experienced to learn that flow, but probably you have a more concrete guide for our viewers.
Yeah, I think it will hopefully be more clearer after we've gone through these 3 different examples here, how the server is connected through the client, and then how the agent can use this client in order to retrieve the tools and in order to perform these actions that we as a user or a developer wanted to handle here. So I think we can go further here to the next example here. So then I think I will start here with explaining some code. So now we're going to have a look at how can we actually develop our own MCP server. So the first thing that we can do is we need to import a library here, fast MCP. So then we can, in a very easy fashion, create and initialize an MCP server. So the only thing that we need to do is we need to find a name here for our MCP server. So in this case, this is an example where we imagine that we have some sort of a factory where we have an inventory of the items that we have in our factory, and we also have some sales figures. How many items do we have in stock, and how many items have we sold in the past here. So we can then create our MCP tools. So we just need to declare it with this @MCP tool. That means that for the MCP server, it can understand that this thing that comes, that is actually an MCP tool that an agent then can use. So in this case, our MCP tool is get inventory levels. So this will return the current inventory for the different products. So for example, you can see we have a moisturizer, we have 6 items left, and the shampoo, we have 8 items left, and we have the body spray. And this, in this example, since it's just an example, we're using a dictionary to contain this information. But we can imagine that maybe we are connecting to a backend system or maybe to a database or something. And in addition, we also have a second MCP tool, which is a weekly sales MCP tool. And here we have also decorated it with this at MCP tools. And then we have this function get weekly sales, which is also a dictionary that returns the number of units that we sold the last week. So for example, we sold 22 items of the moisturizer, 18 items of the shampoo, and 3 items of the body spray. And then finally, the last thing that we need to do is just to run this MCP server. So now we have the MCP server up and running and exposes 2 different tools. One is this, the get inventory levels, and the second one is this get weekly sales. So then the question is, how can we use this MCP server and these tools? So in order for us to be able to use it, we need to create something called a client here. And in the client, what we're doing is similar to what we had before. We're reading from our environmental file, the project endpoint, which is this Foundry project, and also what is the name here of the model that we deployed. So in this case, we deployed the GTP 4.1 model. So when we have that, we define a function, how can we connect to our MCP server? So then we have some server parameters. We need to specify, is it .NET or Python? And what is the name here of the server? So the server is this server.py. Then we can start the MCP server, and we can create an MCP client session here. And the first thing that we would like to do here is we want to find out, the client needs to find out what kind of tools does this MCP server expose. So then there's a standardized ways to do it. So you call session list tools. So by that, we will have a list of the different tools that the MCP server is providing. And we just print it out that now we've connected to the server with a list here of tools. So in this case, we will actually have 2 different tools. And then we create a chat loop so that we, as users, we can ask our MCP server, for example, what is the current inventory level for specific items, or which items had the best sales last week, for example. So we get here the MCP tools from the server. So we do session list tools, then we get these tools. And then we need to build a function. This function is like a wrapper around the tool so that we can, when we access this tool, it's an asynchronous call to this function. So we store the functions here in a dictionary, and then we create something called a function tools definition. So this is also part here of the MCP standard. And then finally here we can create an agent. We give the agent here a name, inventory agent, and then a definition here. So we have the model, our Foundry model, and then some instructions. So here we instruct it to say that you're an inventory assistant, and here are some general guidelines, recommand, restock if item inventory less than 10, and so on. And then we also need to specify what are the actual tools here that our agent, that the MCP server exposes and our agent can use. And then we create here a conversation thread so that we can listen here. We start the thread here with an input, enter a prompt for the inventory agent, and then we start listening to that, and then we send over that prompt here over to the client. That then can use a specific tool here for whatever we are asking for. So I think we can run this and we will see what it looks like. Let me go back here. And then...
Okay.
So then here we can see that now our client is connected to the MCP server, and it also prints out here what tools does it have. So in this case, we have two different tools to get inventory levels and also to get weekly sales. And then I'm going to cheat a little bit here and take one predefined prompt here. So then we can enter a prompt. So we're asking what are the best sellers this week. So when we ask this, then the MCP, the client will send this to the MCP server, and it will be able to understand that it will use this tool for getting the sales, weekly sales. So then we get back here that these are the products that had the highest sales volumes this week. And again here, this might seem like a simplistic example, but it's just here to show that we sort of, when we're using MCP servers and agents, we as developers, we put the development effort into the development of the MCP servers. And usually that could be a totally different department or even a totally different company. So that means that for us as developers, we need to write less code. We are sort of depending on this MCP standard, that by using this MCP standard, we will be able to figure out what kind of tools do we have access to, and what kind of questions or what kind of information can we actually get back using these tools.
Are we done with the demo? Okay.
Yes.
Yes. Thank you for for listening to us. I know that we're running out of time as well, but it was a great demo. If you want to do it in .NET, you can also do that. There's a Microsoft Learn learning path for building AI agents. I believe we do have a presentation of that, but I think we don't need to show the QR code. But if you go to Microsoft Learn and search for agentic AI, or check out the Azure AI Engineer Associate, but I think it's gonna be retiring soon, right, Håkan? What will it be?
Yeah, we can put out the link in the description here to the learning path, so you can see.
We will do that
to our GitHub. We should say that all the code that we run here, we have in a GitHub repository.
We gotta have it in the GitHub repository. So we hope to publish and share this with you soon as possible while we are at the MVP Summit. But otherwise, any final conclusions in this, Håkan, as we wrapped up? What's your advice?
My advice is to try to understand, and the way to understand here is to get practical and try out, and don't be afraid to fail, because that's the best way to learn.
Yes, thank you, Håkan. And I also would like to share my perspective, also putting on different hats, of course, and most especially the hat of being a developer, trying to learn and build things with AI. And I know we use Copilot as our assistant when we were programming, but my advice is to, as Håkan said, to keep learning and don't be afraid to explore and make mistakes and fail. But you have to make sure that you're building quality AI integrated applications as you go in real projects, because when you put in AI in demos or like small projects, it's okay. But if you inject AI and it's not well built with all those pillars and responsible AI that we shared earlier in the theory, it will not be good. And we are I see us as experts and developers as influencers of the future generation of developers and tools that our young ones are gonna build, are gonna use someday. So make an influence by building resilient, quality AI integrated applications. And if you're not sure how to get started, you can always rewatch this video. And there's also Microsoft Learns and fellow Microsoft MVPs that are willing to help us. Like, I'm an Azure MVP, Håkan is AI MVP, but we can help you in most of those technologies that you are still getting started. But if you want to follow me and Håkan, we are actually on LinkedIn. Just search our name. I'm Jonah Andersson in LinkedIn, and you are?
I'm Håkan Silfvernagel.
Yes, and we are also the organizers and hosts of Azure User Group Sweden. So if you want to learn more about Azure, feel free to join us on Meetup And if you're a new speaker and needs a mentor in getting started in public speaking, feel free to reach out to me and Håkan as well. We are also welcoming new speakers and mentor them if needed, if they have a technical knowledge to share to the community. We're like family here, so awesome to be able to spend our time as well in the last hour to share this knowledge, both of us, to you. And I hope that you have enjoyed it and learned a lot from it. And thank you so
Yep.
much.
Thank you so much.
Have a great day. See you next time.